I've been working with Niantic Studio for over a month now to get a proof of concept working. And in this video I will guide you through how I made the visbanken. It is a Dutch term, it's a fish market. I made the fish markets demo in Niantic Studio. So there is one thing that still doesn't properly work. It is the drag and drop. It does work in a regular project, but in my VPS project it does not work. So I will tell you the concept first, then say how I got to this point, and in the future this should obviously work, and I will update any of the and I will put any updates I have in the description down below or in the comments, so make sure to check that out before watching this video. So the idea is that you come to this location. This is a very old fish market, I think from the 1800s in Gouda in the Netherlands, from Gouda cheese if you're familiar. And basically fish would come up here and it would be sorted and sold, and this is how merchants would make money. So what happens is this ship is standing right here. It could be animated, but for now it's just standing here stationary. And you have two baskets of fish here. Ideally this would be put together in one basket where they would be mixed together, but since the drag and drop wasn't working properly, for now it's just the whole basket. But you had to drag the fish into one of these piles right here. So there is a concrete structure right here with two separate baskets basically, and you would need to sort the fish. So these are marked right now with just the fish itself, since it's easier to see something visually in AR than to read something. So you pick it up, you sort it out, and then you have to do this under a certain time. So how have I made this? I will just quickly guide you over the project and how it's set up. I'm not going to do the live development for everything, but it should be fairly straightforward with how I explain it. First, I got the location right here, the visbanken location, and you can do that by going to the maps right here. It should take you to where you live, and then selecting the location right here. And there we go. Here's the location, and you can add it here. Right now it's already in the project, but if I would use this one, you could swap the location right here. So that's quite nice. That works fairly well. Now, once you have the location here, you can see it in the scene, of course. You can say, oh, it's public, it's quality good. Quality good doesn't mean it works great. I had a lot of tracking issues at this location. This is put forward to Niantic as well, and hopefully they will work on that soon. And if you want, you can also download a GLB mesh from this. So this can be textured, no textured, or low poly version. Personally, I got the low poly version, which I tried to download to use as an occlusion mesh. So there are many pillars here, and it's nice if these pillars can occlude the boat right here. On Android natively, this can, or iOS natively, this can run procedurally, but WebAR isn't fast enough for that yet, so that's sadly a bit of the downside. So if you download the low poly version right here, you can put it as a child to the VPS location. First it looks like absolute garbage, and if you put it to hider, that basically means that it will hide any geometry behind it. So if you want to do this, this is the way. If you have a good scan, this will look great. So it will properly occlude the 3D objects in the scene. So definitely give this a go if you're working with VPS. Personally, I don't have it yet, since as you can see there is a lot of artifacting, and that artifacting doesn't look good as there are just floating occluders everywhere. So for me, I didn't use this, but if you have a smaller location, that would be great. For the ship, these are all just quite simple GBLs. I got these from Polyhaven, and it's actually a Dutch ship, so that's nice that it's at least accurate. I got the baskets right here. How these are set up, by the way, all of the VPS stuff that needs to be moved into place should be as a child to the VPS location. That's very good to know. And here for the baskets, I got a mesh, I got a physics collider. I got a lot of bugs when I put this at auto, since when it's at auto, it does a custom mesh collider. That didn't work out for me. I had a lot of issues, and when I did the live debugging, it just made the collider none. That's not what we want, so use a box collider or a primitive collider wherever possible. And I locked the rotation so it can't tip over, since, well, that's not ideal. Then I got the draggable script. I will go into detail on this in another video, and that's the whole drag and drop project right here. It is a great project, and I can quickly show the code, of course, since that's nice. Of course, this will also be linked in the description below, but it basically takes the camera, a distance to the camera, and a speed, and using states, it checks if it's either idling, so physics are enabled and just landing, or you can disable the physics and set them to following. I do see that it's currently disabled for testing, so that will be re-enabled right here. Got it. That's better for the next version. Next, we got the baskets, and I will go into this a bit later. Placement was for animation, you can completely ignore this. And I got, this is very slow. There we go. And I got two basically invisible colliders right here. I didn't want to use the mesh collider because of the artifacting. And these basically catch any object I drop on top of the baskets right here that can collect the fish, or in this case, the full wooden basket. And this is just basically one collider. There's a tray manager, since we call these trays right now. There's a tray manager which basically has a reference to each. And this checks, oh, which of the trays have been put on something properly. So if we go to edit for the sorting trays, so you can see here for the data, we got a correct count. We see if it has touched the left and has touched the right. And in the add, we just simply listen to the collision on the left and the collision on the right. So right here we got listeners to world events, and that's just if the EID of the right tray works, we want to have the start collision event, and we check the right collision, and the same for left. This could be combined into one component instead of two with some manual stuff, but this was just a bit easier to get working. And now what happened on the basket side, that's what we're actually doing here. We're importing basket side from the basket side. That's because we have something here, and this is pretty much empty, so that can be removed to make it more organized. We simply have the schema, and that's a boolean, and the default is false, so it's not left by default. And you can see that right here on the basket side, you can just enable and disable this. And to make sure we can access this from other scripts, we're exporting this. And I'm quite new to JavaScript. I'm mainly a Unity guy myself with C#, so this was a bit confusing to me, but we got it working together with George from Niantic, so that's really nice. And that's why we imported here, because it's exported, and that way we can right here check, oh, we want the data, that's fine. Of the data, we want to check if it has already touched the left side, because, well, if it already has touched it, don't process this again. Then we get the basket side, which is in the world, and it has the other EID. So that's other is the object which is falling onto the static mesh here. So here we see the right tray. If it falls onto the right tray, other is the data that falls onto it. So in this case, it should be the basket only. Then we check if there is a basket side component and if it is left. If it is left, we debug something, we set the head touched left to true, and we dispatch a rolled event for stop timer if it already has touched the right trigger. Because right now we got two objects, so if both are placed properly, we will stop the timer. Sounds about right. Then let's continue to the right side. It's basically exactly the same code, only we want to check if it is the right side. So if it is not left, it should be right, and it should be ready to go. And the other code is pretty much exactly the same. So that's the base of it. Linear movement we are currently not using. That's still in prototype version. And lastly that I want to mention is we got the UI element for a timer right here. So we got time, and this is a script, also thanks to ChatGPT, which basically it's the text in the editor right here. So if we press play, you see the timer right here counts up. And when we find the VPS location, and we get this to touch the... It's harder to do without occlusion, I notice, since... Oh, there we go, that's on there. And then once we get this on here, I'm not sure why it doesn't register the touch. Nope, a bit too far away. There we go, now the timer stops, since we called the stop timer event, which is currently here listening, and then invoking this method, which basically stops the timer, and that's it. It sets the data as running to false, and that's all we need, since this one doesn't do anything if it is not running. So that's very quickly how this project is set up. If you have any questions, of course, put them down below. I will quickly go through the other objects right now as well, since if you're new to AR development, this might be very helpful. We got a plane right here. This is an informational plane for those interested. I'm still getting used to the whole UI here, that the dragging here is a bit chaotic. This is just a plane with a lot of information on it to see, oh, this started out in 1315. And you see the whole history of this object, which is quite cool to see. We got an ambient light, and what the ambient light does, if we get a nice 3D view, basically it controls how intense the shadow is. So if this is disabled, you see here, when something is shadowed, it's completely black, which isn't realistic. So we got the ambient right here. That's great. For the camera, this has to be set to world for AR, and on mobile it will be AR. On desktop it could be either 3D or disabled. It actually might be better if this is disabled here. Near clip, far clip, that you can optimize as however you need. You could set it to 200. I'm not sure if this is in meters. But for now, let's just keep the default settings since it finally is working. You can set the perspective to orthographic for some 3D stuff. But for AR, these are the settings you want. And if you're using VPS, definitely check this box, otherwise it won't work. For the directional light, you can see right here, it's simply set to directional, it follows the camera. Not sure why it has to follow the camera. That's something I would like to hear from Niantic. You can set the color, currently it is too white. Let's, while we're checking it, put this to be a bit more yellowish, since that's usually more accurate. Often a bit more yellow-blue, but for now let's put it at yellow. There we go. We wanted to cast shadows, because that's what I'm going to show you in a bit. We got a shadow plane, and you can here change the shadow biases, which can resolve some artifacting. So now for how I did the shadows in here, I simply got a plane, which is very big as you can see. And the plane has the shadow type right here, and that means you receive shadows onto the plane. So 3D objects that have the... let me see... Oh, it's on the mesh itself, I think. Yeah, right here it can cast shadows and receive shadows. Those are the baskets. For us, we're just going to cast shadows since it saves performance, and the baskets don't really need to receive any shadows. So let's try to keep this as optimized as possible. But it should receive the shadows onto the shadows plane. The resolution sadly isn't the highest. I haven't found how to increase the shadow resolution that easily. But this is a very easy way to get shadows working in AR, so that's really nice. We got the collector right here. These aren't that special. These are just the fish to show you how it works and where you need to put down the basket. Same for this. And collision was a bit tricky. We had to get a giant box collider underneath to make sure it doesn't fall through. Since even when using a box collider, if it's very small or narrow, stuff can pass through it. So that's quite rough to not know what happens, since you're mostly debugging in here, and sometimes you're debugging on the device itself. And physics issues are often hard to find. And I just recommend to put a big box underneath, and that fixes a lot of issues. Just make sure it matches the actual starting point, as seen right here. So that's basically how this project is set up. If you have any questions, of course, definitely let me know. I will try to answer everything I can. I'm also still relatively new to Niantic Studio, and stuff is rapidly changing, so it can be that I don't have an answer to every question, but I would love to help out, so definitely let me know if you have any questions. And I hope to see you in the next video, because in the next one we will go over how to drag and drop stuff in Niantic Studio, which is a very nice interaction for sure. See you there.